All right, so I think it's now 2:30 here, so we can start. So I'm Tero Kivinen, one of the chairs here, and my co-chair is waving there. All right, and our responsible AD is Deb, who is not here yet, I guess. But anyway, so let's go forward. So this is the new note well. So you are supposed to be I'm supposed to be reminding you that you have already agreed on this when you registered into this meeting. So it's pointless to read it now because you have already read it and checked out everything. It's just a reminder that you have done that. And the QR code will take you a page that has all the links and so on. Okay, now we need note takers, and one of my note takers just ran out. But I guess Anthony, you can do, and you can poke the next person next to you to make minutes when you are giving presentations, or the one who is looking around having nothing to do. Okay, and there is already template, and if people can actually go there and check out what people are writing down, and only the questions and comments and that kind of things, no presentations, no need to. All right, let's go to the agenda here.
There's also the AI. There's also the AI that is taking notes.
Yeah, I don't think it takes notes. It takes a summary, some kind of summary. Okay, so these are our new agenda. There's one presentation that was supposed to be there, but it was didn't get slides in time, and I removed it. Or actually, also he had to go out. He wasn't able to come here, so that's why I also said that he can cancel his, or he will cancel his presentation. So, okay. Any comments on the agenda? And of course, people will notice that any other business is probably going to be 15 minutes because the open mic is 5 minutes, right? Okay, so this slide is wrong because this was done on Sunday. And in Sunday, we didn't have any new RFCs. Now we have 3. All of the ones that were in Out 48 are now published, which is a little bit, we have a little bit differences in, how quickly we do things. One of those, documents went through from the first, 00 to the published RFC in less than 1 year. The other one took more than 15 years. So the GIC version 2 has been, the first version of that is March 2010. And, the renaming ESN was, first version was, 2024 December. So it's there's a big difference in how fast we are actually working. Okay, so we have 3 new RFCs, and we don't have anything in the publication queue. There probably will be about 4 documents in the queue quite soon after this one, because we have 2 waiting for the write-up. I think I have already got this volunteer to be Sherpa for one of those. And then we have 2 more, and it has been in last call about a year now, because there were some issues that need to be solved. So the diet ESP extension and diet ESP. And one of the things is that they are actually waiting for this DSCP NP draft, which we at one point didn't want to work on because there was not that much interest. But I think because it's required one of those, I think we should probably just publish it or put it out as an experimental. So not a standard track, put an experimental, and then people will implement it if they like it, and then we can get this diet ESP stuff out. So I will probably start, when the authors publish this as an experimental, I will do a working group last call for that, for the, DSCP NP as an experimental, and then we will publish all of these. And I don't have currently any documents waiting for the working group last call, but I'm pretty sure that after this meeting we will have some that are saying that, or some of the presentations will say that we are ready. And then if the note takers mark it down in the minutes, then we can actually do it. So we have quite a lot of documents in the working process. We have SETS payloads opt, which hasn't seen any traffic for some time. Reliable transport, I think that's supposed to be quite ready. Downgrade prevention might be ready. Beat mode, I think that's also, we have a presentation of those. ESP Act version 2. The ESP ping drafts seem to have died because I haven't seen any discussion about those, any comments. And my understanding was there was supposed to be combination happening, and but okay, they are working on the implementation, and then okay, PRF plus and SHA-3. So those are the current working process documents. And we don't currently have any working group adoption calls, but I also think that is going to be changing after this meeting. Okay, then we come to the presenter. Or any comments on the drafts? Okay. Okay, let's go to the presentation. The first one is child PFS info. Valerie is online, I guess. Yes. So.
Hello.
Yeah, I will pass you the slide controls.
Okay.
Okay,
Oh, great.
Now you should be able to move the slide back and forth. Go ahead.
That's strangely that it started from 6 in my. Okay, just a moment. Okay, slide number 1.
Oh,
okay.
At the beginning.
It's yes, it's the beginning. It's the draft that was. Oh, okay. I understand the issue. I understand the issue. It's
go to the page. Something like this is the combined stuff, so you have to go.
Yeah, I see. So what is it? It's number 6, 7, 8. Okay.
2 more.
2 more.
1 more is.
Okay. So this draft was published a while ago, but then after some discussion among the authors, the author of this draft, Paul, and the authors of the optimizer key, we came to conclusions that it can be redesigned to simplify its implementation. And so the version 0.2 is rewritten, and so that it is now presents a completely different approach to getting child PFS info. So quick recap from the problem description. So when IKSA is initially created, and initial IKSA is created 2. And for initial child assay, there is no separate key exchange. So we reuse the key exchange that is done for IKSA in the IKSA init exchange. So for this reason, it is not negotiated. The key exchange method for child assay is not negotiated. So, and when the initial child assay is later rekeyed, or another child assay is created, so peers have to negotiate a key exchange method for the child assay because it wasn't negotiated when the initial child assay was created. And if the PFS assay, child PFS assay policy is different on the peers, so it may be a surprise that after you have several hours of working child assays, the next child assay cannot be created. So since this becomes evident only after some time when you initially created child assay, it is not a very good thing to operators. It's a bad surprise. So this draft tries to solve this problem by negotiating the key exchange method at the time the initial child assay is created. So what we can see from RFC 7296. It explicitly prohibits the key exchange method, it is called Diffie-Hellman groups, to appear in ICE assay payload. And we propose to leave this prohibition so that all the full set of transforms for child assay is negotiated in the ICE as if it is create child assay exchange for a key child assay or for creating another child assay. So this allows to perform full negotiation of all child assay transforms, including key exchange methods. And they persist exactly as if it is done in the create child assay exchange. So for example, if there is no mutually accepted key exchange methods and initial child assay is not created, there's no proposal chosen. So the problem of mismatched child assay policy becomes evident at the time the initial child assay is created. And if it is created successfully, then the peers do know that they have mutually acceptable key exchange methods and the next rekey will succeed. Oh, unless the policy is changed in between, but that's another problem. And the key exchange method that is negotiated in the ICOs is not used at all in this draft. So the fact that negotiation is successful is matters. The key exchange method that is negotiated doesn't matter at all because it will be renegotiated in the create child assay exchange in the next. But for the other, I could say V2 extension, for example, for optimized rekey, this method can be kept and reused. That was the intent. And well, if policy change that, the fact that changed after the IKSA is created, the child assay policy, child assay PFS policy is changed, then there is no guarantee that rekeying will succeed, but well, it's a different problem. So if policy change, perhaps you can just recreate the IKSA too, because you change your policy, and so it's a little bit different problem. Well, what's next? So, well, to present a key exchange method in the ICO, the peers need to negotiate that they will present, they will negotiate key exchange method in the ICOs. So for this reason, we introduce a new identification, child assay PFS info supported, that is exchanging the IKSA needs, so the responder is not chopped if it sees the key exchange method in ICOs that is prohibited by RFC. So that since it is negotiated, there is no need to update RFC 7296 because it's an extension that doesn't break interoperability with unsupported implementations. And just some thoughts, if peers are not going to rekey initial child assay or create another child assay, for example, they create a short-lived ESPSA, then perhaps they don't need to negotiate that extension. They don't need to use it because it's an additional reason for child assay not to be created if they have mismatched child assay policy. So in this case, they just create an initial child assay and it is deleted and never rekeyed. It's just some considerations that implementation may take. And well, okay, when RFC 9370 is supported for multiple key exchanges, that all what was told about key exchange methods should be treated not just key exchange method, but key exchange and additional key exchange methods, so they are all negotiated. So it's just, for simplicity, I didn't mention it before. It's just a note that should be considered. So, well, the draft optimized rekey, it was discussed and we decided that it should use PFS info draft to solve the problem of optimized rekey of initial child assay when key exchange methods are not yet known. So it is currently normative normatively references PFS info draft. For this reason, it cannot be forwarded unless the PFS info draft is adopted and is published as RFC. So that's why I think this draft should be called for adoption, and Paul and I believe that it is ready for adoption. So please adopt. So comments, questions, Scott?
I strongly support Scott Fleur, Cisco Systems. I strongly support this draft, not only because other drafts reference it, but also it solves a real problem, and it does so very cleanly. Thank you.
Thank you. Andrew?
Here we go. Andrew Cagney, LibreSpawn. I guess that's my affiliation. I just had some technical things. It's called PFS. Should it be called CAM instead, since that's the new speak for everything to do with key exchange methods?
Pardon? Can you speak a little bit
Sorry,
loudly?
sorry. The name is called PFS, which is a generic thing, but the specific transforming negotiated is a CAM, and the additional CAMs. Would the CAM be in the name be better?
Yes, but the transform is named key exchange method in IQT registry. For this reason, it can be a Diffie-Hellman or CAM, post-quantum CAM. So we just use the name of transform that is named key exchange method, KE method.
Okay, I lose. And can you tighten the proposal to say you shall use the same proposal negotiated when the child is rekeyed? Can that be changed to a shall? Or
well, there is no such if you put we assume that the child essay policy doesn't change since initial child essay is negotiated. If it doesn't change, then we can require, but it's natural that you use the same policy for that you propose in the IC oath. You will use the same policy in the create child essay when the essay is rekeyed. So it's in this case you will propose exactly the same methods. Of course, if your policy changes, then there is no guarantee that you propose exactly the same key exchange method as you proposed in the IC oath. So, but it's a different problem. You can run into the problem even without this extension. So, for example, you can create later a child essay, then your policies change and you will rekey this child essay. And so, if your policy has changed, you probably have to delete IC essay and recreate it. But it depends how your policy has changed. For example, if you add additional key exchange method, additional algorithm, and doesn't remove any, then perhaps you are safe to keep the current essay running because you just add more options, but you doesn't remove any options. So
okay, thank you.
All right. So I think that I don't see anybody in the queue anymore. So I think I don't see any reason why this shouldn't be adopted, and I will start an adoption call probably after I get back from Bangkok, meaning in 2 weeks, because I don't have time to do it before I leave to Bangkok. No, because I have to check out what kind of emails it's actually sending out. It will send an email also in that case. Yeah. It sends a different kind of email. Yeah. All right. So next one is enhanced ESP. Okay. That should be working.
Yeah, hi. I'm going to give a quick update on the announced DSP draft. So first of all, some words about the changes we did since the last IETF, then some words about the new implementation status, and as the last, some open questions. So changes, yeah, we released one new version and we basically did two minor changes. We removed the packet format flag from the base header and we changed the content of the cipher block padding. That's basically all we did. So let's have a look at it. The base header as it was looked like this. Highlighted in red are the flags, and this had one bit which contained a packet format, and it turned out that this is redundant. So we removed it because it's just not needed. So the new header looks like this. So instead of flags, we have 3 bits reserved, and the comparison is this. All the flags, news reserved. That's all we changed in the header, nothing else. Okay, the second thing we changed is the content of the cipher block padding. So we started doing the same as ESP is doing, which is just an increasing sequence of the cipher block padding bits. And as we agreed last time, we removed that and just set the padding bits to 0. And yeah, that's basically all we did. So the draft is quite stable, just 2 minor changes since last time. Okay, so let's go over the implementation. In between, we have an implementation for Linux. We worked on the hackathon on it, and we got it ready to work. So at least we can ping through it without kernel crashes. We have the code there. You can just check it out. This is my kernel branch. Yeah, if you're interested, look into it. Okay. That's basically it. And then we have 2 open questions. So one thing is, should we keep transport mode or not? Some people came to us and asked, do we really need transport mode or should we just focus on a tunnel mode with the new protocol? And yes, I mean, we understand that just tunnel mode would make things much easier, but we still think there are use cases for transport mode, so we tend to keep it. But we also want to hear opinions from the working group, whether it makes sense to keep it or not. So please comment on that. Hello? Okay, and the other thing which we have is currently we have the payload info header as a default for tunnel mode, but actually we do not really need that for tunnel mode. It's just used for transport mode. So we have 4 users bytes in the tunnel mode, and we plan to remove that from there. And so the question to the working group is that okay? And that's basically all I had. So there are 2 open questions. One is keep transport mode or not, and the other thing is should we keep the payload info header as a default in tunnel mode, or should we just skip out these 4 users bytes? That's all I had. Thank you.
Some routers use transport mode a lot.
Okay.
So I think getting rid of it would like kill their use case or dramatically increase overhead.
Yeah, I feared something like that because that's the reason why I tend to keep it. Yeah.
I'm sorry, can you clarify your last statement? I didn't.
Yeah, we tend to keep it for that reason. But
okay. I thought you said you weren't going to keep it because of that use case. I misheard you.
We plan to keep it because we thought there are use cases, but so far nobody really spoke up, say, well, we have this use case here. So we just wanted to make it clear that somebody comes and say, yeah, there's a use case, and thank you for
use
that.
Case.
Pavel, this individual. Yeah, I've gone through trying to kill this before, like I think 5 years ago during the 8223, 8247 RFCs, and I failed completely. So yeah, people are using this whether we like it or not. Also, I think some NVIDIA cards only support transport mode. So
I think in between there's support tunnel mode as well.
They're given as an individual, not as chair. So one question I have about the transport mode is that my understanding still is that we are going to be having the old ESP around. So the question is, are those who are using transport mode, do they actually need to have enhancements done in EESP or not? If they are not getting any benefits from EESP, then of course the question is, would be okay to have a transport mode only in ESP, and EESP would be tunnel mode and more simpler, perhaps even optimized more on that use case. That's the
Yeah, I think yeah. So use cases from Google, for example, who had the PSP protocol, they are basically using transport mode, and I think this is a kind of a use case that we should cover with this protocol as well. So I think it's there.
I think that there may be applications for transport mode even for EESP. For example, multicast is, if you consider to use EESP for multicast traffic, multicasting usually done with transport mode. It is tunnel mode is supported, but this tunnel mode is just a redundant tunnel mode because the IP addresses from the in and out headers are usually the same. So it's with IP preservation. It's called tunnel mode with IP preservation. Is just a waste of traffic. So transport mode can be more efficient. So there might be some considerations for using transport mode even for EESP.
Christian Hopps, I'm one of the co-authors. I don't know if Lou is specifically referring to this, but I know I've heard that it's very common for GRE for people to have deployed ESP with transport mode over GRE tunnels, and I think that's like, yeah, what's that? GRE over transport. Oh, yeah, right. But I think that's the big use case. I don't know. I just thought we would call that out instead of come at it sideways. And presumably, Tero, the only reason I'm saying this is I think that you said, what is the use case, right? Or do we need it for EESP? And I would guess for the same reasons they need it for ESP, they probably want it for EESP.
Yeah, I was meaning that usually the transport mode is for host to host type of thing, when you have your laptop talking to,
that was the design,
in
right?
that case, most of the times you don't benefit for the, you are not requiring EESP. You can do fine with ESP. But if there is a use case that are, doing this kind of benefits from EESP, then fine. It's just questioning because I don't know the use case. Actually, he didn't know the use cases, so I was asking.
Yeah. No, that was the one that
Okay,
we were
so
thinking
if we
about.
need it, then it's fine.
Yeah. Thanks.
Okay, so we agreed to keep it, right? Yeah.
Tim Winters. I think OSPF v3 auth uses IPsec transport mode all the time. So I wouldn't get rid of it just based upon that, or you should at least tell people that's what you're going to do.
Yeah, but as we are, actually, what we were talking about, they are using ESP, they are not using EESP yet, which means that the question is that are they actually going to be moving EESP is a completely different question, right? They have been, routing issues have been very slow to move to the, just this TCP authentication option. I think they're still trying to move at some point from MD5. Yeah, no. Okay, but okay, so.
Okay, that's it.
That's it, okay. I don't think you get any feedback from the default tunnel mode, but I think the authors are free to do whatever, decisions they want.
Yeah, it's just a minor change. I think we just do it. I mean,
yeah, just do it. I mean, these are still, All right. Okay.
Thank you.
Okay, the next one is EESP Egg version 2. Okay. Let's see. This one doesn't, so it shouldn't. I tried to pass it again to you. Hopefully, it doesn't go to the beginning. Okay, now you should have just go forward.
Yeah. Yes. So this is a companion document for EESP. It reflects what changes are made in EESP and try to add the possibility to negotiate or to somehow configure these options via IP2. For ESP, since it was adopted, there were very few changes, and one of that Stephen just described in previous presentation, and one of the changes that wasn't present in the initial ESP IP2 draft was the ability to announce the maximum crypto offset options. And so we, in the new version of the draft, we just add the ability to announce what the maximum crypto offset peer can accept as a receiver. So for this for this purpose, we added a new notification that is called maximum crypto offset ESP max crypt offset status notification. So this is not negotiation. Each peer just sends this notification with a data that is 1 byte long and contains a value that is a maximum number of bytes that can be in the crypt offset option of ESP header that this peer sending this notification is receiving. And it is 1 byte long, so the maximum number is 255 bytes, but the crypt offset option is only 6 bits in the ESP header, so it's enough. And well, okay, as I said, there is no negotiate, it can be different values in different directions. And if this notification is not sent at all, then it means that crypt offset cannot be, that the peer isn't ready to accept any value in crypt offset other than 0. So it doesn't support crypt offset options. It doesn't want to receive these packets. If its peer just ignores this and sends this packet, then this packet are dropped, and it should the connection should be teared down. So I think that's all. It's a very few changes. Any questions? Andrew?
I'm Andrew Cagney, LibreSpawn. Probably pushing my luck, but for the CAM, the whatever it was, the KDFs, you've used 0 as none or null or whatever. Can I plead to not do that, having been through the grief of the KDF, the previous thing where 0 was magically assigned a meaning after the initial RFC? I'd rather see something like cipher null being given a meaningful number rather than 0.
You mean announcement of maximum sub-assay that peer can consent. So if this number is 0, then the peer says that it doesn't accept any sub-assay, and for this reason, KDF is not used for deriving a session key. Is it right? So is it your question, no?
Yeah, I understand why it's there. It's could you use a value that isn't 0? Because from an implementer's point of view, you know, the standard way to do some code is to grab a buffer, 0 it, and then start poking in meaningful values. With 0, with this risk that did the other end put in a meaningful value of 0, or did they just screw up?
Well,
from the protocol point of view, it's just a number. It's just a choice. But from an implementer's point of view, 0 gets risky in that you don't really know if the other end put in something meaningful, whether they just, let it slip through. Something to think about.
So this argument, you are talking about this maximum number of incoming sub-essays, right?
No, I'm talking about the sub-essay KDF. Sorry.
Sub-essay
Yes.
key derivation.
Yes.
Okay.
Yes.
Yeah, because with Diffie-Hellman groups, the original RFC avoided 0. They didn't realize they would need to do none, but then later,
No, actually, the none, 0 was always reserved for none.
yeah, it was missing. If you want to do none, you left it out. Then
you
later
are
it got-
allowed to leave it out, but
Sorry.
but it's also always meaning none.
Right, but later it got retrofitted to have 0 also mean none. And I'm not sure.
No, that was there in the beginning.
No, not in one of the early drafts. It got added to a redraft, I believe.
Oh, yeah, okay. It might be. I don't remember. It's 20 years ago, so I don't remember the draft thing. But I think in the first RFCs it was still allowed to have. But anyway, yeah. So you're saying we should have a instead of leaving out the essay key derivation.
No. It's you can leave it out. Cool. Or if you're going to put it in there, use a value that is not 0.
Okay.
That's all.
Can you bring this to the list so that we can discuss it on the list?
Yep.
Okay, thank you.
So I was going to ask to clarify, is your concern that it's a security concern? Like by default, it's going to be 0. And if the default of 0 is don't encrypt, then you're going to leak things and be insecure?
No, it's a hacker screw up concern, to be blunt. So people forget to carry values over. And if you're putting a meaningful value in, you can see in your packet, then yes, someone's actually done a value here. Whereas if you get a 0, you're never sure what the other end has been doing. Anyway.
Okay, bring it up in the list, and we will. I think this is reasonable, thing to do. All right, the next one, downgrade prevention, and we have already the slides, so I can pass you the,
Yeah.
So, where are you there? Oh, actually, sorry, I passed it to the clicker.
I still don't have the button.
Yeah. Yes. Use this one. Use that.
Oh, I'm in the queue? Someone's in the... Still have questions. All right. This is my first IPSEC in person. Thanks for having me. So let's see. Okay. So so this we recently adopted. Okay, so the background here is that IKV2 is vulnerable to downgrade attacks. Basically, if you have an initiator and a responder that prefer a strong key agreement, then they both support some weaker key agreement, an active attacker can downgrade the connection to use the weak key agreement. And the reason this is relevant right now, this was first observed 9 years ago in a pretty cool paper at IEEE S&P. The reason it's kind of coming up now is we're adding MLChem to the key exchange. So after Q Day, anybody who supports both Diffie-Hellman plus MLChem and Diffie-Hellman only is vulnerable to this attack. It's, this isn't the only way this problem manifests, but this is, because we're doing this now, this is why it's coming up now. So the fundamental vulnerability is that in the initial key exchange, each party is going to authenticate only its outbound message, and it doesn't confirm which message it got from its peer. And this is kind of be the core thing that this draft tries to fix. It provides a way for the peers to confirm they've had the same conversation. So so this draft has been adopted. I think we went back and forth for a while, but we all seem to agree that there is an attack here that matters, at least in theory. But I just want to quickly go through the attack so that we're all on the same page. So this is one variant of the attack we call in the draft identity misbinding. The idea is that you have a responder who's configured to to speak to a couple of initiators. We call them V and A. A is the adversarial one. V is the victim. Hence those monikers. And the attacker is going to want to. It's going to be on path between the victim and the honest responder, and its goal is to decrypt traffic sent from the victim to the responder. So they're all configured to sign the handshake. So each has the public key of their peer. And so the receiver has the public keys of both the victim and the adversary. And again, the adversary is just a party in the system that the responder is already configured to speak to. So the idea here is the attacker is going to intercept an IK init SA message sent from the victim. Let's say this message has two proposals, one for a strong key exchange and one for a weak key exchange. What the attacker does is it rewrites that initial message to drop the proposal for the strong key exchange. So when the receiver gets that, it thinks, oh, I guess I'm talking to someone who only speaks Diffie-Hellman only, so we're going to downgrade because I have to, because it appears I'm talking to an older device. All the attacker then is going to do is forward that response back from the responder to the victim initiator V. And the victim says, oh, I guess R only supports Diffie-Hellman only, so let's downgrade. Now, here's the hard part. The adversary is going to intercept that IKE auth message from the victim, but it's encrypted. However, it's encrypted using the weak key exchange, a key derived from the weak key exchange. So what the attacker has to be able to do is online decrypt this thing so that it can then rewrite the message that was encrypted. And in particular, so that it can sign the forged IKE init SA message. So instead of init v proposal 1 proposal 0, it just says init v proposal 0. So this is the cryptographically hard part. This is where I'm breaking Diffie-Hellman, or I'm breaking a key exchange algorithm that has an implementation flaw or something like that. The weird thing about the identity misbinding attack is that the attacker has to sign with its own key. So now the receiver, instead of it thinking it's talking to the victim, it thinks it's talking to the receiver, to the attacker A. On the other hand, they still manage to finish the connection. So V thinks it's talking to R, but R thinks it's talking to A. However, when V goes ahead and sends that first message, the attacker is going to be able to intercept it and decrypt. So that's the attack. And the way we're going to prevent this is by authenticating more messages. So in particular, imagine the protocol had been that the receiver confirms what message it received. That is, it signs the IKE SA init that was sent by V in the first phase of the protocol. Then the victim would have aborted. It would have been like, oh, that's not the message I sent. Then the key exchange fails and I abort. So what we're doing in this draft is we're going to override the authentication logic to do just that. Basically, we're signing the entire initial exchange rather than only the outbound messages. And this is an obvious thing to do. It's exactly what we do in TLS today. The tricky part is that the support for the extension is always going to be notified in the IKE init SA message. I hope that's actually how people say it. I apologize if I say it incorrectly. Therefore, if you implement this extension and you see that your peer notifies support, then you're always going to use the new authentication logic. Again, this basically is, so if we successfully successfully negotiate this extension, then we are authenticating now the entire handshake on either side of the connection. And so this is in particular the bytes that we're signing. So on the left we have what the peer what we sign if we don't notify support, and this is just the existing thing. And then on the right is what we sign if we do support, if the peer does notify support for the extension. So imagine kind of thinking through this attack. The reason this works, let's imagine the victim adds the notification to its initial message, and then the attacker rewrites it by removing it. The client is still going to sign. It's the client. The initiator V is still going to sign the message that it sent, which did include the proposal. The notification. And the server is going to fail. The responder is going to fail to authenticate because it saw a different message. Okay. Before I go on to working group feedback and next steps and open issues, does anybody have questions about the protocol or the attack? Just understanding stuff? Nobody online? Okay. Yeah, go ahead.
Maybe one question. Why do you add the 0 prefix?
Oh, that's a good question. We're trying to have some domain separation between the two signatures. So like on the left is the old logic, on the right is the new logic, and we want to make sure those are always different strings that we're signing. Just domain separation.
But then is the size of the 0 prefix the size of the size of the concatenation on the left, or?
I don't remember the size offhand. If Valerie's online and wants to jump in the queue.
Well, 0 prefix is a fixed size. It's 8 bytes and 0 bytes. And domain separation works because real message 1 and real message 2 both starts from initiator SPIs. It's never cannot be 0. So these strings and old logic and new logic will always be different. So that's just a reason. Well, the reason is domain separation, and Chris just thinks that it's a good thing from cryptography points of view. So we just do it to be on the safe side. I don't think if it is really needed, but I think it's won't hurt.
Yeah, it just seemed like a sensible thing to do. Thank you, Valerie. I appreciate it. Ben.
Hi, this is Ben from the UK NCSC. I've not been following this too much, but a while ago I seem to remember that the attack required one of the peers' signing keys. Is that not the case, or is that no longer the case, or was there another attack?
Yeah, so that's another variant of the attack. That one is called key compromise impersonation. It's also described in the draft. That was the variant described at 123. This is the sort of stronger variant that was initially described on the list. KCI is a little easier to present. It took me a little while to get through the other one, so sure. That's why we did that. But yeah, there's possibly other variants as well.
Okay, yeah, I'll sit down and figure this out. But does this mitigation protect against the attack where you've got the signing key as well?
Yes.
Okay, perfect. Thank you.
All right. In the interest of time, let's move on. So Ben, you're back in the queue. There's, I think, based on the discussion on the adoption call and what led up to that, my read is that there's consensus that most people believe that this attack is real, at least in theory, and that the proposed mitigation is sufficient and not too difficult to implement. So, even if it's just theoretical, maybe worth doing anyway. As speaking of implementations, Valerie's has implemented this himself in his own in his organization's own stack. If anyone wants to do an implementation, say in Strong Swan, I can send a PR, or I'd love to see this implemented sooner rather than later. Okay, yeah, but okay, so not everyone agrees that the attack is relevant in practice. So, for example, we can mitigate this by disabling support for weak key exchanges. So by Q day, we should have disabled Diffie-Hellman anyway. The problem is older clients, and also there might be deployment scenarios where you don't know out of band whether your peer supports PQ or not. And yeah, again, and this is also pretty far in the future. Like, it's not relevant till Q day. Hopefully, we've done the migration by then. I think there were a number of people who felt, well, yeah, I mean, but this is like a theoretical problem with the protocol that's exploitable if you ever have like an implementation bug or anything like that. And also, the attack is online. You have to do it. You have to decrypt something. You have to break Diffie-Hellman online, and that's expensive. But yeah, I think my take on that is, the strength that quantum computers will have on Q day. It will be very expensive to pull off this attack, but things get cheaper as technologies scale up. So I wouldn't hold out for that. So there was a couple of suggestions. One was to mention PPK and how that might be used for mitigation. Yeah, you can use PPKs to mitigate this attack, but you have to mandate it. But there's some text in the draft to cover that. And also, it was suggested by Wayne Guillian, the initiator and responder shouldn't sign the same messages in the same order. And Valerie and I agree. And go ahead and took that change. So yeah, I agree. This draft is probably pretty much done. The only open issues to discuss, one is substantial, which is how do we compose this with a session resumption? We have a PR up which proposes just indicate the negotiation status in the ticket. So if you did negotiate it, have that status in the ticket. With the idea being that the goal of session resumption is to preserve the security of the session that you had before. So no need in particular to try to renegotiate downgrade prevention. And then the other one was naming. What should we call this? Valerie and I picked a name we don't think is particularly great. So if anyone has any other suggestions, let us know. Yeah, so next, before we go to working group last call, I would like to see open source implementation. I want to ask what you all do with code points. Should we ask IANA to register something early? I don't know how you all do that. Anything else? So that's it. Time for discussion. Tero?
First, as a chair, so yes, there is me and Valerie who are the code point, experts. So we can give you code points, but we don't want to give code points until we know that the draft doesn't change anymore. Because we have had these issues that we have given out numbers and then suddenly the meaning of the numbers change. So that's why they get. As long as you are still, when you are comfortable that now we have fixed everything, we are not changing any, trapping anything, so then we can get the numbers. Before that, we can use the private numbers.
Sounds good.
And then, and yes, I think we can, yeah. So as an individual, one of the comments you were saying that, okay, you are saying that it's getting cheaper and cheaper to do those. I'm not sure that actually is necessarily true for online attacks. Even if you have a huge quantum computer, have huge number of bits, you still need to do quite a lot of steps. And these steps takes time, and you might not be able to do those in 60 seconds, regardless of the size of the computer.
Yeah, even breaking RSA 512 is very, very expensive, and you're not really going to pull it off online today unless you have a huge amount of resources.
Even with the quantum computers, there's going to be lots of steps still. So we don't know how many steps, we don't know how big, and so on. So it might be that this actually never is going to be, reasonable attack because of that, but we never know. So that's why it's better to fix it now.
Yeah.
As someone who's actually studied the various attacks, basically the computation that the quantum computer would do is essentially the same as or actually 2 times the computation that you do during the key exchange, the Diffie-Hellman. It's just that it's done by quantum computation as opposed to classical ones, and that is the factor which would require the increase. and we don't know to what extent they'll accelerate.
Yeah.
All right. Any other comments on this?
Yeah. So if we're going to, if I don't hear, I'll poke the list one more time. And on this open issue here, we're gonna, if no one comments on this, we'll merge it, I guess, in a week or so, if that sounds reasonable to the chairs. Other than that, bike shedding on the name would be useful.
Yeah. So Daniel Vengis, not a cryptographer, but and regardless of the difficulty of the attacks, I'm told by people who are cryptographers that this change actually helps to, because you're authenticating the Diffie-Hellman of both sides, it helps with security proofs of the multiple key agreement.
Yeah, for sure.
Extension. So in that case, I support it regardless.
Thanks.
That's something that probably should be mentioned in the props.
Yeah, good point.
I just want to comment a little bit. So Chris said that I've implemented it. It's true, and the fix is really simple. And it took me half a day and about 20 lines of code. Out of 20 lines of code changed, it was login and if devs. So it's really very simple fix that can allow us to be on the safe side for any situation. So that's why I think it's worth to do.
All right.
Anybody have ideas for names? All right.
Cryptographers usually just pick some random number and use that as a name, like 775. I don't know. So don't ask names from cryptographers.
I like
you ask names from the people who make attacks because they make cute names.
All right. Thank you, everybody.
And actually, yes, I would really like to have people in next hackathon to do some testing on this. Unfortunately,
if there are any additional implementation besides of mine, it's
all right.
It will be great, and you can test anytime, even right now.
Okay, the next one is Valerie again.
Okay.
I will post you the fast slide.
So, okay. So CAM-based authentication for IQ2. This draft was initially written by Gulin, and I joined as co-author, and we made a concrete key exchange that I will explain. Concrete, not key exchange, authenticated key exchange mode for IQ2, and that I will explain. So first about the motivation. And you know that in case of mostly used CAMs, now it's MLCAM, and mostly used post-quantum crypto stuff that is used now, it's MLCAM and MLDSA. If we compare them, then MLCAM is 50% shorter, about 50% shorter messages, and about 5 times faster than MLDSA. So MLDSA is really more expensive in terms of computing power and message sizes. And that's the reason. That's the first reason why people look at the CAM-based authentication. It's this time. And additionally, CAM-based authentication can provide us with some interesting security properties that are not available with signature authentication. So that's our primary motivation for this work. And we know that there is some history of authentication modes that don't use signatures, but use asymmetric cryptography. We can tell about MQV and HMQV, the early works, and I think many of this working group remember that IQ1 had public key encryption authentication mode and revised public key encryption that exploited RSA encryption without RSA signature. And the current efforts in this direction, we can mention two drafts in the TLS working group for CAM-based authentication. And at the IETF 123, it was a protocol PQ8 was presented in the Lake and in the IPSECME working group sessions. So it was presented by Yuri and Brandon, and there are some interesting properties with this protocol. It has a security proof. It decreases the number of post-quantum asymmetric key operations to only one signature, one offline signature to verify the certificate, and all other computations are CAM computations. So at that time, Yuri presented a draft that incorporated this PQ8 protocol into a doc and into the IQ2. And integration with IQ2 was very, very unoptimized. So it was just it just used intermediate exchange with full PQ8 and didn't use IQ2 existing IQ2 features at all, or almost at all. So we tried to integrate PQ8 into the IQ2 with more optimal way and reuse existing IQ2 properties as much as possible. So the resulted protocol is not PQ8 because we have to change it. So perhaps it will need re-evaluation, but still it is CAM-based authentication. So just outline what PQ8 is. So the peers first perform ephemeral hybrid key exchange. Then they exchange long-term CAM certificates. Then they perform key exchange using these long-term certificates, so resulting in two shared secret SSI and SSR. And then they confirm to each other that they know this SSI and SSR secrets, respectively, and use this secret in deriving session key. So session key also depends on this secret. So how we incorporate this protocol into IQ2? So we reuse existing IQ2 features. So peers rely on IKSA need for an ALIC as intermediate as per RFC 9370 for ephemeral key exchange, ephemeral hybrid key exchange. They rely on just published RFC 9867 for optional group PPK that can add security for protecting identity of peers when they exchange certificates. We add an option to rely on hash and URL because CAM certificates can be quite large and they do not change frequently, so it is possible to just download the certificate and reuse it if you make several connections with the same peers. So hash and URL fits very, very nicely into this paradigm. We use intermediate exchange for exchanging CAM certificates and encapsulated SS keys. And IOS is used for key confirmation. So downgrade prevention is supposed to be used. It is highly recommended because it will authenticate the whole transcript. And RFC 9593 can also be used to announce supported methods, authentication, not authentication, in this case, not authentication methods, the supported algorithm in long-term CAM certificates. So now this is a sequence of exchanges. I apologize for the dense slide. I tried to show the whole picture. So a little bit about notations. So in the center, the name of exchange is shown. In parentheses, it is RFC number or which defines this exchange, because for intermediate you can do it for various purposes. Then the key derivation, what key derivation is performed after this exchange is shown. And what about the color? In green is shown the new notifications, new payloads, and in black or gray, it's an existing. So first an IXA NEAT is performed in according to RFC 7296. It's standard with no changes, except that P negotiates that they will use CAM-based authentication by the exchange of use CAM notifications and new notifications. Then peer do optionally, but within that, in most cases, it will be the case. They will do hybrid key exchange. So the next intermediate exchange will do CAM, suppose, for example, MLCAM. And in this key exchange, we can also negotiate, not negotiate, but exchange the PPK values. So it is allowed by RFC 9867 that PPK can be piggybacked with other in the intermediates that perform some other purposes, for example, CAM. So we just eliminate an additional intermediate by piggybacking both MLCAM and exchange and PPK negotiation of the concrete PPK to use. So after this, we update SK shared secrets so that it depends on additional key exchange and on PPK. So the next one is the new intermediate exchange for the outcome, the first outcome. The first intermediate exchange, the first new intermediate exchange for the purpose of outcome. It's just exchange long-term CAM certificates. It doesn't update keys. So the next is the second intermediate exchange for outcome purpose. It's just contains of the new notification outcome data that contains an encrypted SSI values encrypted with public key of the peer. So it's actually the CAM, the exchange, CAM exchange to CAM exchanges based on the long-term peer certificates. And after that exchange, the session keys are updated again using these SSI values, SSI and SSR. And then ICOS exchange takes place that confirms that completes all the authentication. That's the outline. So the session key, how they are computed. Once the intermediate exchange completes, the second new intermediate exchange. So it's the last intermediate exchange before ICOS. So a new SKI seed value is generated based on the just exchange SSI and SSR values and SKD, the current SKD values. So that the ultimate session key depend on this SSI and SSR too. So they depend not only ephemeral key exchange, hybrid key exchange that was done in the beginning, but also on the key exchanges for outcome, for long-term, using long-term certificates. And new notification. So use outcome is a very simple notification just to negotiate. Outcome data is to exchange SS values. And it is, the data is concatenation of two values. It's a suffix corresponding, and the second values is ssconf, either ssconf or ssconf r. It is needed to confirm that the peers actually receive the key that was sent by the other peer, because there can be a misconfiguration. For example, when private key doesn't correspond with the public key in the certificate. For example, after certificate update, you can update private key, but with some delay update the public key that is, for example, in the certificate, that, for example, is located somehow and it's accessible via URL. So in this case, the peer that encapsulate SSI will encapsulate one value, but after the encapsulation, the peer that use their own certificate will receive a different value. And since we immediately steer these values into the session key, they are also will be completely unparsable. You will receive garbage. And so to prevent it, to detect this, we cannot prevent this, we can detect this. It is ssconf values is used. So along with SSI, this identification contains some data that depends on the along with the ciphertext CT. This identification data contains some values that depends on the shared key values, SSI or SSR, and that is bound to the session. So in this case, to SCAR PX. So the receiving party can check that it received exactly that SSI or SSR corresponding values that was sent. So misconfiguration can be detected. So it is very similar to what is done in RFC 9876 with PPK, so that we protect ourselves with this configuration errors. So, it's a slide that explains everything. I just forgot about this. So I think that is written exactly that I just explained. So, Scott, do you want to ask a question now?
Yes, might as well. I've glanced through it. It doesn't feel right. Has it gone through any sort of formal security validation? One concern I would have is some sort of, you don't seem to have any liveness check in your CAM authentication. So I would be concerned if there's a way for someone to do a replay, a previous authentication from someone else.
I'm not sure. Actually, ssconf is bound to the current SCAR PIBR.
Okay, it is
values that are bound to the session.
Okay, I didn't see that binding. I must have missed it. But I would still ask if there is if it's gone through formal review.
PQ8, as I was told by Yuri and Brandon, has a security proof, but
yes,
I haven't seen it.
Yes, yeah, but this
It
is not
not
PQ8.
I understand. Actually, Brandon, well, the draft was written with Yuri and Brandon looking at it, and Brandon said that from his point of view, it is sound, but he has to evaluate it more deeply. And okay, if you have any concerns, then please bring them to the list.
I will need to go to review it with a fine-tooth comb. Just that fine details matter.
Okay, thank you. Chris?
Yeah, Chris Patton, Cloudflare. Yeah, I guess I share Scott's concern. But let me just first say, like, I think this is I think actually chem-based authentication probably makes sense a lot for IKE v2 because we have these already 2 rounds. I think it would be, we would definitely want to get more eyes on this. I wanted to suggest, I'll suggest someone who might actually get excited about looking at this. Actually, well, Tom Wiggers, who proposed off-chem for TLS. He might have a look at this and have some ideas. So I'd suggest we chat with him.
Okay, thank you. Scott, you are in the queue. Some other question or not? Okay, so I'll continue. Well, so our payload is calculated as in case of IP methods, key generation IP methods, so using SkyPI and SkyPR, that depend on SSI and SSR. So, and perhaps we need a different string for domain separation. I'm not sure, but well, okay. So what about announcing new auth method? So the announcement is, the format is exactly the same as for signature, but the authentication method is different, just to it's a new authentication method called CAM authentication. And the format includes algorithm identifier, so that peers can announce which CAMs they have certificate of. So they have CAM long-term CAM certificate with some CAM algorithms that can announce which algorithms they have certificates for. And so, well, there is some nuances on using announce method, because since the CAM-based authentication requires a completely different sequence of exchanges, you cannot announce both signature and CAM-based authentication. So you negotiate CAM-based authentication via a separate notification. Since once you negotiate it, you can announce only this auth method, but perhaps with different CAM algorithm. So it still has values. And so security properties. We believe the security properties of IPv2 are preserved, but of course it should be reevaluated. And we have some interesting new security properties like full repudiation. Since no data on the wire depend on the peer's long-term private keys, each peer can repudiate that they have participated, the fact of participation in the communication to the third party. And another interesting property is that since CAM-based, the long-term CAM certificates are used, the SSI and SSR are bound to the session key, are steered into the session key, that you have post-quantum security even if your ephemeral key exchange is not post-quantum secure. For example, you can do just Diffie-Hellman and doesn't do any hybrid key exchange. Of course, you can degrade some security in this case because private, you can decrease identity hiding in this case, but you will still, the ultimate session key for the IQSA will still be post-quantum secure. So it's just some side effects with this. And so you see that there are two additional icon-intermediate exchange to perform CAM-based authentication. So the draft has a section that discusses an alternatives. So can we eliminate one additional key exchange just to reduce overhead? So the amount of data exchange on the wire will be the same, but the number of round trips is possible to decrease by one, but with some drawbacks and some perhaps degradation of some properties. So the current picture, so you have two icon-intermediate exchange that needed for our scan. So we can just move exchange of certificates into the previous icon-intermediate exchange. In this case, certificates are not protected. They are protected with the keys derived from IKSA, but they are not protected with the key derived from this icon-intermediate exchange. That can include CAM, some CAM or PPK. So while certificates are public data, so perhaps it doesn't matter, but identity hiding will be decreased in this case because observer, an active observer can see that can break, for example, Diffie-Hellman can see which peers participated in the exchange by just breaking Diffie-Hellman. So this can be improved a bit if we moved initiation certificate into the next icon-intermediate exchange. In this case, it will be protected at the same level as the original sequence, but responders certificates will be still vulnerable to observing by the peer that can break Diffie-Hellman. So what we can do? The next modification is very weird and complex, but it is still possible. We can protect this certificate with the future keys. So respondent at the point can calculate a keys for the next intermediate exchange. And it can encrypt or I don't know, protect, authenticate this certificate with these future keys, the keys from the next exchange. So for this purpose, some wrapping should be done with some, for example, new notification payload, and it will require some changes in the implementation. Not from my point of view as implementer, not very simple. But in this case, we will have the same amount of protection as the original sequence, but with one intermediate key exchange viewer. So it's up to the working group to discuss whether it is feasible, whether it is reasonable, or just original sequence is very straightforward and very simple and very understandable. It's just a way for optimize it. So thanks, comments, and perhaps an adoption, because there is some interest in this topic, and all the details can be settled in the discussion in the working group.
I didn't see any comments and discussion or anybody, but we can bring it, please. And I think, yes, I think we got to start adoption call for this side. Let me see. I think going through your, your comments about 3 different versions, I think we should pick one, and I think, it's something that we can work on when we have it in the working group. That's it. All right, so there is nothing else for comment that. Let's go to the next one. We speak you hybrid in the I was doing with product game.
Okay, thanks. Yeah. So, okay. Oh, okay. I do it by myself?
Yeah.
Oh, thank you. Okay. So this is Fredo KEM for the IKEV2. Yeah, so this is general information about the draft. Yeah, so my generation is that actually Fredo KEM got a good support or recommended by European country authorities. So we do think it is a good KEM scheme for post-quantum key exchange as a backup, for the MLKEM. So here is a little bit of history about this document. So basically, actually, before this 0.0 version, actually, myself already have 2 versions, something like nearly 1.5 years ago. Yeah, so from the version of 0.0 in this suite, so actually Leo and also Valerie joined the draft. Yeah, so this is probably the main change. Yeah, we also restructured the document. And when we did a presentation at Bangkok, yeah, for this one, we summarized a number of the discussion, about the Fredo and its suitability for IKEV2, etc. Yeah, so we summarized it in our presentation slides. So basically, we can say we have over 20 discussions with most supportive, based on recommendation as we mentioned from European authorities for the Fredo KEM algorithm. Yeah, so you can find the detailed summary about these discussions on our presentation slides. Yeah, also you can find the original email discussion, from this link. Yeah, and we got the main comments is that we should reduce the code points because Fredo itself actually provide 12 variants, different security levels, using different hash function, and also has 2 something like this. Yeah, totally 12 actually. Yeah, so then we reduce the code points, from 12 to 6 in our version 0.1. Yeah, and we tried to give a presentation at a 1 to 3 meeting, but because they're not available for the time slot. Yeah, so but we get several of good comments. Yeah, especially the comments from Scott, together with two comments from Chris and from Craig, yourself. Yeah, so get comments. So next, I will going to tell what we did is this version. Okay, so the current version is 0.2. Yeah, so we did the first thing. We reduced the code points from 6 to 4. The main reason is that actually we found, so the recent progress in ISO, FreeDO will be standardized by ISO, probably by the end of this year, around the end of this year. So on ISO standardization will be only for security level 3 and 5. So in that case, we don't not necessary to standardize level 1 in IETF. So we can reduce it to from 6 to 4. Yeah. So we also addressed the comments from Kevin, on the ephemeral variants of FreeDO KEM. Yeah, because this one we consider because the main thing of FreeDO is that they have two main versions, one for long-term K, one for ephemeral FreeDO. So because this in our case, we prefer ephemeral one because we suppose the key exchange for IKEV2 mainly for ephemeral. Yeah. So we also actually make a notes about the downgrade attack that just praised by Chris. It's also got get the comments from Chris. So we should make a notice for this one. But basically our draft is about the key exchange. Yeah, downgrade attack is for authentication. But we do suggest, or actually we ask the master to do this one to support the downgrade prevention, according to Chris and Valerius draft. Yeah, the next one is a good question from Scott. So we explained why both versions support AES and Shake are available, why we still look like to support both of them. The main reason is that FreeDO has this kind of two variants, such that to offer optimize the performance. So across different hardware platform. AES variants are highly actually suitable or very good performance if we have the actually hardware acceleration instruction code for AES. Yeah, so like the AES AI for Intel processors, and the Shake is actually more general. Even if you do not have particular hardware acceleration instructions, actually Shake variant is more efficient. This is the reason. Yeah. And the last one, Scott also suggested we should actually specify the payloads for the KEI and KER more specifically. So we did this one, like get a short section. So thanks a lot. For KEI, KER, basically we just need to use these two payloads to send the temporary public key for the FreeDO KEM. And then the responder will send back the ciphertext. That's it. So basically, actually, the draft is not so complex, just like a particular initiation for to support multiple key exchange for post-quantum stuff for IKEV2. Yeah, so the framework, is introduced by RFC, 9317. Yeah. So we do believe, currently the draft is quite mature. So we would like to ask group adoption. Yeah, thanks a lot. Yeah, questions, please.
All right, I think the first one in the queue is Daniel.
Hi. So maybe that's a question for Scott. Do you have a? Did you ask for? Suggest to pick one of AES or Shake?
I did not have any particular opinion about which one would be better. It's just that it strikes me is that they are two similar options, and there's no reason to have two similar options at different parameter sets. Now, what I don't know is what is the magnitude of performance difference between Shake and AES on the two various platforms. If it's large, 50%, makes sense. If it's like 2%, probably not.
And we are talking about key exchange,
Yeah,
which
good
happens
question.
every 8 hours or
So we
something.
check more about the particular numbers, the comparison. Yeah, but the general comment is that. Yeah, thanks.
Ben?
Hi, Ben, UK NCSC. So the ephemeral Frodo variants are ephemeral. You can't reuse the key material across handshakes. But RFC 7296 permits you to reuse key shares across multiple handshakes. So if you're going to use the ephemeral variants, you'll need to have extra text in the draft to say, by the way, don't reuse this. Is that there currently? If
We
not, it
just
can be added.
cited the recommendation from the Fredo design team, especially they have a say FIG draft. It mentioned, okay, if you use ephemeral Fredo KEM, yeah, the multiple times of you can use the same public key to do encryption is 2 to the power 8. It means 256. Yeah.
Okay, whatever it is, it should also be in this draft just because it will override
we haven't mentioned this one.
7296.
Yeah. But actually, one more thing I would like to say is that we are also considering, so if we just change to long-term Fredo KEM, basically what we know is that the two versions actually, the performance difference is very small. So we send an email to the SafeRG team to ask their opinion as well. But this does not too much. We just select one of the version will be okay. Yeah,
yeah,
we
using
can
the
decide
long-term
like
one would
this
be fine
later.
as well.
Not a big issue. Yeah, thanks.
Cool.
Thank
you.
Yeah. Andrew, please.
Andrew Cagney, LibreSpawn. Just to comment on what Tero said about 8 hours. From the experience in the field says what matters is the CPU performance, because you can get servers doing thousands and thousands of these things a second. So yeah, it really matters.
Okay. Yeah, we can check this one. Yeah. Hope we can find some good literature. Otherwise, maybe we have to do some
I didn't put myself in the queue, but if you're talking about high-end servers, they have AES acceleration. Therefore, those AES variants become far more interesting.
Okay, thank you.
All right. So I don't see anybody else in the queue. So let's go forward.
Thanks, everyone.
Let me see. Next one is somebody stole my clicker.
Yeah, I stole it. Okay, so this is about shoving classic McAleese into the key exchange CAM in IQ2. So let's start with what is McAleese. So I'm quoting from Josephson draft. It's a key encapsulation method designed for int CCA2 security, even against quantum computers. This is from version 03 of the draft. So McAleese was introduced in 1978. We have current documents from 2022, mostly because of the NIST contest. Key agreement requires a large public key and a small ciphertext. So when the initiator sends a public key, the responder small ciphertext, and the difference is really great. I mean, for the most common parameters, you get a 1 megabyte public key and about 208 bytes of ciphertext. So there's a lot of interest in this from places. There are all sorts of drafts. But trying to write this draft, there were some challenges. So the biggest challenge is sending out this 1 megabyte public key. So an IQ2 payload, if you want to shove this public key into the KE payload, an IQ2 payload has a 16-bit length, so you can get 64 kilobytes. You can't fit a 1 megabyte public key in there, so we need to transport larger payloads. Fortunately, I have a draft called IPSECME big payloads. So we could use that. But even if we have that, doesn't solve the problem, because IP and UDP, therefore UDP are still 64K, even with IP layer fragmentation. So you still need IK message fragmentation. That's RFC 7383. But then you might be tempted to think, well, if we don't use UDP, we use TCP, then we can have a stream as long as we want. But that doesn't work either, because TCP encapsulation, RFC 9329, doesn't really solve it, because we have this length field that's only 16-bit. What were you thinking? So we still do want TCP, because if you take this 1 megabyte payload and you want to send it over IP, whether you do the fragmentation at the IP layer, at the IC layer, or at the TCP layer, that's 700 packets. And for reliability, you want to be using TCP. So you really need RFC 9329, even though you still need also the fragmentation. But that's not a lot of it. There's still more. So both the big payload and the fragmentation need to be negotiated in IKSA init, and then you can use them in the next messages. So you need the intermediate exchange, and you need the additional key exchange extension, because you do have to do some kind of key exchange in the IKSA init. So let's count them. We have got the big payload, the fragmentation, the TCP encapsulation, the intermediate exchange, and the additional key exchange. Are we getting this? I'm getting this feeling that IKV2 was not created to transport 1 megabyte public keys, but we're not done yet. Because other work in the IETF is draft Joseph of McAleese that just describes the algorithm. There's Jeff Josephson SSH McAleese that does this through a construction called the Champat in SSH. There's Jeff Wagner that does things like that for TLS. And of course, there's our draft. So what are we asking now? We're not asking for adoption yet, but because for the purposes of key exchange, I don't think there's a lot of difference between IKE and TLS and SSH. We're all using the same algorithms. We're likely to all be using the same encoding. So rather than each protocol having its own draft and perhaps reaching different conclusions, I mean, draft Josephson has 12 parameter sets. There are really 3 parameter sets with the plain text, the PC version, the non-PC version, the F version, and the non-F version, that we get the combinatorial explosion to 12 different parameter sets. So we should pick 1 or maybe 3, but definitely not 12, and get those into all 3 drafts by the time they're ready for adoption. However, there are things that we could try now, that we could do now in the IPSECME working group. And first is to adopt the big payload, which will need any kind of way we want to transport McAleese public keys, unless we want, I don't know, to hash an URL for public keys. And the other thing is the transport separation draft Smyslov IPSECME IKV2 reliable transport, which allows us to use TCP for the IKE because we need it, and then go back to ESP for, well, the traffic. And I think that brings us to the big question slide. Yes, Tero.
They're giving it. So if I remember correctly, the reason why we have a TCP have this stupid 16-bit, length in the beginning was because this came from outside the IETF in the beginning. There was some telecom people who were doing this, and they wanted to have this standardized, and they wanted to have the 16 because they have a running code. But it doesn't mean that we can actually change it, because there is an, IKE TCP, stream header in the TCP stream. So there's a version negotiation type of thing. So we could actually do this kind of things that we could perhaps, negotiate it, to have it, using 32-bit, length field in the TCP, and it would actually solve some of the problems at least we don't need to use like fragmentation in the TCP.
Mhm.
The other option would be, of course, use the hash and URL type of thing, meaning if the 1 MB key is if it's going to be same for, I don't know if that actually is it going to be same for a long time, or is it going to be changing for every time? If it's going to be same for a long time, we could actually just use a hash and URL for that also. That would allow us to just send a hash in our in IKE, and then it's the same than last time. We don't need to fetch it. It's a different. We need to fetch it, and and so on. Just these kind of things that we so we could. But I think yes, we could actually adopt those two things and work on these on our working group also.
I think even a bigger idea would be, we're using a lot of extensions all the time, and everything needs some extensions. Maybe we need a Nike v3 that folds in all those extensions, but that's a topic for a different different presentation. Yes, Valerie.
Well, I think that big payload can also be useful for our CAM if CAM certificates, for example, contain some very long, well, anything that is larger than 64 kilobytes, not even MAC release, but perhaps from SLH DSA with some extensions that can exceed 64 kilobytes in length. So there is another application. And there's another thing that I want to tell is that I have experimented with classic Mac release in the test lab using big payload. And well, it's local, it LAN, it works. Not on UDP, of course, using TCP. Well, actually, I tried to use a UDP with the smallest parameter set for Mac release. It's 300 kilobytes, and sometimes it succeeded, but not every time. But, well, actually, it is an interesting experience. So it works. Not very fast, but less than a second. Usually, you can negotiate Mac release.
Yeah. I mean, the big evil plan for big payload is to make CRLs work again by sending megabytes of CRL in the IKE exchange. That's the dream.
We are not supposed to say that in loud, did we? All right. So next, I don't see anybody else in the queue. Or okay, so let's go to the next presentation, which is going to be beat update. Okay, and that should be working now.
Hi, I'm Anthony. So this is a this draft name suggests it's an update. It's actually taking one part of the RFC 74402 and making it as a standalone document of its own. It's mostly driven by Bob Moskowitz, and I'm one of the co-authors of it. And, initially, we didn't notice the problem when we beat mode is specified in there already, but even though if you look at the minutes of the IETF for last 10 years, that a lot of times you see that people think it is expired and it is never specified, which is not true. It was already it was hiding in RFC 7402 Appendix B. So then we want to take it out and make it a standalone document. And while we are doing it, we would like to propose also one minor fix to support IPv4 fragments, because IPv6 fragments are already supported. So to get the future parity with v4 and v6, we're proposing that it can be done. So this is the whole thing we noticed, because when we were proposing to v2 negotiation for beat mode, to get a code point, then we thought, oh, well, we need the beat as a standalone document so that it can be referred in the IKE2. It is already used in places where there's no IKE negotiation, and that's what it's been mostly used. But some of the IKE implementations also supported it and used it using the private negotiation. So now the minor fix I'm proposing is because the IPv4, the beat mode essentially takes the inner payload and puts it inside, and the IP fragment header is outside, which cannot be copied inside. So we are using a beat mode as this thing called pseudo header, which can carry the fragment information inside the encrypted payload. And once you decrypt it and recreate the packet, put it back on the IPv4 fragment will be used as a fragment. So this is a simple pseudo header we are proposing, and it's already used for IPv4 options, and now we're proposing to use it for fragments and options and the combinations of that. There was a 8-bit reserved field, and from that we are taking 2 bits of it and making it as option only padding or IPv4 options, or when combination with IPv4 fragments. So that's a simple change we were trying to propose here. Simple draft, we can go through it quickly, and once this is adopted, we will advance the IPv2 draft combination with this.
So this is Deb Cooley. I'm your Sec AD. Can you go back, I don't know, a couple slides? Keep going. Keep going. There. Okay, so you already have this specified in Appendix B of 7402, correct?
Yes.
You just want to make a change. So you're going to pull out that stuff out of 7402, make it a new document, make the change.
The one behind you.
I know he is, but let me get it out first. So is this an update? Is it?
We don't know. We came up with the update to start this discussion and end somewhere, and we are not strong on like to attach to update. Or initial idea was BIS, and which is like I know you you would even be more mad at it, but
right. Well, okay. So we'll hear what he has to say.
So if there is a better suggestion.
Bob Moskowitz. What? Okay. In this draft, sections 3.1 through 3.7 are practically a direct lift of Appendix B1 through B7. Pretty much a little bit of cleanup of the text, a lot of reformatting to meet modern standards for how to format stuff, which was actually the big work was doing that. The addition is section 3.8. 3.8 is the update of that's being done to what's in 7402. So when you look at this, realize that sections 3.1, 3.7 is what's in Appendix B. And it's 3.8, which is the new piece that Anthony has added and provide the text for how that works.
And we added some introduction and abstract because abstract of the 7402 doesn't even fit anywhere near this.
So if somebody picks up 7402 and implements it, they have no indication that there's a.
So that's actually what I was asking Bob. So 7402 is the HIP, host identified payloads, and is HIP going to be using this standalone beat mode, or are you going to be using the Appendix DB in the future?
Once you adopt this, then I go back and I have to update or do something to 7402 to now point to this as an addition to beat for the B4 fragmentation. It's like going to plead to the appropriate ADs about how to pull that off.
So what you want to have both the HIP and IPSEC to use the same new version with the same new extensions.
Because it's going to end up in the kernel code. So right now you have beat as is defined is in the kernel code. So now you're adding 3.8.
So the other option would be that the IPSEC working group would actually go and update the 7402 HIPS thing for its own and HIPS uses, and that's why we want to take it out from the appendix. And perhaps we will make a very short document for that updates for the 7402 HIP document and says that the appendix B has now in this RFC. Go look at that.
Right, yeah, something like pulling out Appendix B and says, go look at this new RFC for how beat is done. Oh, thank you.
So,
okay, thank
so
you.
not that was to him, not to you. So who are the ADs for 7402? Because it's not me and it's not him.
It's a closed work group, it's like it was.
What area?
It was done. Was it done in the int area back then? It was kind of a
I
strange
think it was,
beast.
it was Stephen Farrell.
Ted Lemon
Stephen
was,
Farrell, whichever AD grew he was.
no, it was
What AD?
Ted Lemon was the AD for the 7402. Yeah,
No,
that's
it's not
what
SEC.
it was. Hip working group was in. I think it was in Intera. Yeah.
Oh, Intel.
I doubt it. Yes, it's my problem. Tomorrow? Not tomorrow. Not tomorrow. I'm flying home tomorrow. Monday.
But I'm probably loud enough. Sorry, it's Thursday. I mean, we're not going to have two things written in two different places that are different.
Yeah.
Because that's just insanity.
Yeah, that's why we want to, do this in a sync. And of course, the problem is that HIP has always been this orphan thing that is should have been in security but wasn't.
I mean, you're going to have to update 7402 to say this crap in the appendix isn't here anymore. It's over here.
Yeah.
Well, this was never our idea.
Okay, so we are not going to be doing the last call. We are not, adoption call yet until we get the int area, and the HIP stuff ready.
Okay, God. I will do that. I don't know if I can do that today. Yeah.
All right.
There are deployed use of HIP in corners of the internet. So it's got like if this comes a kernel change for adding this in, yes.
All right. So that's not going to be adopted until the other things are solved.
Thank you.
Okay. So then we come to the open discussion, and we have about 10 minutes now. I have some items that I put in here. We have several experimental RFCs, and I have a question for implementers. Are you supporting any of these? Are you using them? Should we actually at some point and think about, should we lift them up from the experimental status if there have been enough experiment with them? Or should we just, decide that this experiment failed and, move them historical or something like that? And I think at least the childless initiation of IKSA is something that people are using. I don't know about the others. And actually want to get the comments into the list, not in here. This is mostly for talks, but you can also talk now. Andrew is the first.
I was going to say childless initiation of IKSA. We don't do what the RFC says, but it happens in the real world with security labels. Because of the security label, you establish the IKE, and then some later point you establish the children.
I think there's a second page is the password authentication methods, which we couldn't put any of them in standard track because we couldn't agree on any of those. But anyway, so think about these.
I'm drawing blanks.
Yeah, so think about these and put an email to the mailing list if you think that any of these are, worth of going forward. And then we have
Pretending to be an AD, but I'm not. Could you send a message to the list with this thing so we can respond to it and figure this out?
I can do. Okay, then we have one more, I think, slide set now. I should have stops. So this is the reordering. Okay. You have about 5 minutes, I think. Then we are run out of time. There's a clicker.
Thank you. Hi, everyone. So I'm Chris Box. I wanted to
let you know about some other work that's going on and to ask for your input on it. So this is talking about BCP 89, which was done 20 years ago, and it's advice for subnetwork designers. And so it talks about what should they do, how should they carry these layer 2 packets. And one of the things it says in there is reordering is inevitable in the internet. I.e. out of order delivery occurs all the time, particularly where you've got multiple links. So you've got a lag group, packets being distributed across those, or if you've got retransmissions going on, which is more across wireless links. So that's happening all the time. And some, in fact, if I move on, yes. So there they are. So the link aggregation is one cause, retransmissions are another cause. So so things like 5G and Wi-Fi and DOCSIS, they all have standards to require those links to put the packets back into order. So they go through the link, they arrive out of order, they then get reassembled back into order before they're delivered to the endpoint. However, this is not always helpful. This is obviously increasing latency, and adds cost and complexity. Now, when this was written 20 years ago, it was needed, even needed for TCP, because TCP behaved badly if packets arrived out of order. That's no longer the case. So we're just looking at can we update the guidance to tell the subnetworks, okay, you can be a bit more relaxed about that. So yes, that is the aim. So the reason I'm here is because there is we believe that there's, or at least there used to be, IPSEC that had an issue if there was out of order delivery. And I think the issue was with replay protection. And so the question is, if we update the guidance to say there's more relaxed approach, would this create problems? If so, why? And is that solvable in some way? Or should we, when we update the guidance, should we say that the link should look out for this particular traffic and handle it differently? I.e., still do the resequencing. So that was it, really.
This document. So we have had this discussion already in IPSECME because we have had issues, with the reordering, and people are usually, that's one of the reasons why we have go to the EESP discussion, because there were people complaining reordering. Usually, if your reordering is small, less than 60, I mean, usually the replay window is 64 packets or something like that. So if it's less than that, then it usually doesn't matter. But the problem is that in some cases, especially when you have multiple links, like one going to satellite, one going to different thing, then you're gonna have really big reordering happening, and that's causing trouble. So that's why we haven't work on EESP and so on. So we have seen this issue,
yeah,
and we are trying to cope it in ourselves also. So, yeah, and Anthony is going to be next in the queue.
So the RFC 9347 IPTFs is more stricter on reordering. And when it tries, if it's, I think the reordering is more than 2, it will drop the fragments. So you may want to look at that carefully. That is not nothing to do with the replay protection. That's a different one. So the 9347 specifically says if it's out of order with 3 packets,
and the reason for that is mostly for traffic flow confidentiality, and it's sending packets in the constant rate, which means that if they go reordering, which means that there is no more constant rate, so the traffic flow confidentiality is, and the packets are not useful anymore because they are not like that. That's the reason why it doesn't allow reordering. That was Scott.
Okay, Mike, talking about Tero's comment about terrestrial link versus satellite link, I don't believe you're asking the question in that context. You're asking Yeah,
Really?
you're asking in the context of we have a link which sends packets mildly disordered, and then does it have to forcibly reorder them?
Yes.
There, I do not believe the packet ordering matter is jumbled that much, and IPsec can tolerate it to some extent, as Taro said, typically up to 64, sometimes rather larger.
Great. Okay. Thank you. That's really useful.
All right. So I think that was all we had. Any other business we have? 30 seconds. Daniel.
Yeah, so I had a document that describe how we can detect ESP fragmentation, and I talked to the transport AD, and so what he's proposing is that the TSV working group can look at it, but I mean they're ready to look at it if IPSEC is mentioning, I mean, as at least aware and asking for TSV WG. The draft.
The draft about the what was the name
ESP fragmentation.
ESP fragmentation thing. The one that we actually couldn't get to really agreement on, and because we wanted to have a TSV people actually look at it, and they wanted that, and
I think one of the big question is if they want to do more than simply notifying there is a fragmentation. I suggest I fear that it might interact with the ping in ESP or so, and I haven't looked yet at this ping
Well,
in ESP.
Can you bring that to the list? Send the email to the list, and then we can we are then notified about that. Okay, I think that's everything we had. Okay, thank you.
Thank you.